January Leeetcode challenge, and I hope you're enjoying the daily challenges. Today's question is a simple question wherein you're given two sorted lists and you need to return a new list that is the merger of the two lists. Also, you need to keep in mind that you are not allowed to reallocate memory for each node in the new list. You need to reorder the previous two list or reorder the next pointers of previous two list to generate the newer one rather than creating a new list altogether with more memory occupied. That means you need to do in place. So let's have a look at the example. You're given 1 2 4 1 3 4. The merge list is 1 1 3 2 3 4 4. Let's walk through the slideshow that I have created for the algorithm, and let's start. So here you will see multiple test cases. The first one, so in interviews, it's very important to think of test cases before jumping onto the actual solution. One of the probable cases, L1 is null, L2 is not null. In that case, return L2. The other case is the reverse of this. L2 is null and L1 is not null, return L1. And for the case where both of them are not null, you need to do the merge logic. You need to add your merge logic there where it will actually execute. What is a merge logic? Before jumping onto the merge logic, always remember to create the dummy node, which I have been telling you in the previous videos as well. Linked list questions, dummy node is a mandatory thing. It reduces the verboseness of the code, unnecessary if-else checks. Let's assume we created a new node, dummy node, that will be the head of our new linked list. And these two are the two linked lists given to us, 1 3 5 7 2 3 9. I have taken a case where we will observe equality for the sake of completeness. What we need to choose, we need to choose the minimum out of these two. Which one is the minimum? One is the minimum. What we will do, we'll point the dummy node's next value to L1. So we updated this node and we incremented L1 to point to L3. This point, L1 gets there. When L1 gets here, what options do we have? 3 or 2? Which one is the lower one? 2 is the lower one. We'll update the pointer, this next pointer to the minimum value. The minimum value will be this one, and L2 will be incremented to the next value. Something like this, which is shown in the slideshow. So this gets updated, L2 moves to this position. So L2 moves to this position, and what L2 moves to this position, and now which one to choose among 3 and 3. Since the values are equal, you are free to choose any of them. For the sake of simpleness, let's always choose the L1 value. So we chose the L1 value, this gets incremented, and we chose L1. L1 moves to the next pointer, and now we have two options, this and this. So, sorry, I skipped one slide. So first we chose this, then we chose second, then we chose 3, and now we have two options, 3 and 5. Which one to choose? We'll choose 3 because it is a lower value. So hence this node gets updated, L2 gets updated, and this gets removed. This is what is being shown here. This gets incremented to the next one as 5 and now you have two options, either to choose 3, either to choose 9, or to choose 5. Which one holds the lower value? 5 holds the lower value, so you'll increment this node to this place, and you'll increment L1 to the next pointer. L1 gets here, something like this. And between 7 and 9, which one holds the value? L1 points to 7 rather than 5 now because we've already selected 5. Between 7 and 9, 7 will get that value because it is lower in nature. So this node gets established as shown, and once it reaches next we move to the next pointer, and this becomes null. We'll add whatever is remaining in the other list. Suppose there were multiple 100 nodes after this, so you only need to establish one connection, something like this. That next pointer will point to the remaining nodes. Once you are done with the complete logic, you'll return dummy.next, which is our initial dummy variable that created, because that will be the head of that will be the actual head of our merge list. Here it will be this node. Let's quickly walk through the coding part. So defining a node, dummy node as new list node with -1 value if L1 equals to null. Remember our first test case, I'm writing that. Return L2. If L2 is the null, return L1. Otherwise, if both of them are not null, we'll do the manipulation logic. Let's define 3 iterators. I1 equals, that will point to list1 first pointer. L2 will point to list2 is the iterator for the second list, and list node IT is the iterator for the new node, which will point to dummy node. And let's start the iteration while it1 is not equal to null and it2 is not equal to null. Till the time both of them are not null, what we are going to do, we'll check for the lower value. Which one is the lower value? L1.val is less than it2.val. it1 is a lower value in this case. What will do, it.next equals to, will point it's next new merge list next pointer to it1, and will increment it1 to it1.next. Also, we'll increment it to point to the next variable, it.next. Otherwise, for the other case, it.next equals to it2, it2 equals to it2.next. Exactly the same case, it equals to it.next. Once we are done with this logic, what we need to do, we have iterated both the list, some part of both the list, and at least one of them is null. We will now check which one is not null, which field is not null. So whatever nodes are remaining, we'll just point it to that. So while it1 is not null, in case it1 is not null, we'll simply add pointers to the list without even checking which one is the lower value, because the other one is already null. If it2 is not null, for the case it2 is not null, we'll just add values to the new pointer, irrespective of whether it is the lower or not, because the lower doesn't come into picture. The other node is already null. So either of them will be true, maybe true, or both of them will be true. Either of them will be null, or both of them will be null. It can't be the case that both of them are not null, because that will be handled by this while statement. And once we are done with the logic, we'll return dummy node.next. Let's try this up. It passed, and let me just submit it. Thanks for watching the video. And the time complexity for this algorithm is order of n plus m, where n and m are length of the first list and the second list. So total time complexity would be order of n plus m. Thanks for watching the video. Hope you enjoyed it. And we are also not using any extra space apart from few pointers for iteration. So SC is constant.